The moment you bite through that smooth milk chocolate coating, everything just works. The crunch of roasted peanuts, the stretch of golden caramel, the softness of nougat. It's like each layer was designed to complement the others perfectly. And honestly, that's exactly what happened. Back in 1930, Frank Mars wasn't just making another candy bar. He was crafting what would become the ultimate snack that actually satisfies, naming it after his family's beloved horse, Snickers. Nearly a century later, that same carefully balanced recipe has made it the planet's best-selling candy bar, with people reaching for it in over 80 countries worldwide. But here's what makes it truly special. Creating this perfect balance requires 4 completely separate production lines, each one dedicated to crafting a single layer. Today, we're stepping inside the factory to see how 15 million of these satisfying treats come together every day, layer by careful layer. The Snickers story begins in 1930 with Frank Mars, but here's what most people don't know. He actually failed twice before creating the perfect formula. His first attempts were too sticky, his second batch too hard. It wasn't until he discovered the secret of temperature-controlled layering that the modern Snickers was born. Named after his family's racing horse, this candy bar would go on to generate over $380 million in annual sales, with American factories alone producing enough bars daily to stretch from New York to Philadelphia if laid end-to-end. But creating this American icon requires more than just mixing ingredients. It demands industrial-grade precision that would impress NASA engineers. Deep in the heart of Texas sits one of the most advanced candy manufacturing facilities in North America. The Mars plant in Waco operates on a scale that's difficult to comprehend. 24 hours a day, 365 days a year, this facility processes over 500 tons of raw materials daily to feed America's insatiable appetite for Snickers. What makes this operation extraordinary isn't just its size. It's the split-second timing required to coordinate 4 completely different manufacturing processes. While chocolate tempering requires temperatures within 2 degrees of perfection, nougat production demands humidity control so precise that weather conditions outside can shut down entire production lines. The facility employs over 800 workers across 3 shifts, each trained in food safety protocols so strict that a single contamination could cost millions in recalled inventory. But the real challenge isn't safety, it's consistency. Every single bar must taste identical, whether it's produced on a Monday morning or Saturday night. Creating Snickers chocolate begins 3,000 miles away in specialized storage warehouses where cocoa beans are aged like fine wine. These beans, sourced primarily from West African cooperatives, undergo quality testing so rigorous that only 40% make it to the production floor. Once approved, the beans enter automated roasting systems that can process 2 tons per hour while maintaining temperatures accurate to within 1 degree. The roasting profile, a carefully guarded trade secret, takes exactly 22 minutes and develops over 600 different flavor compounds that give Snickers its distinctive chocolate taste. The roasted beans are ground using industrial mills that generate enough friction heat to warm a small house. But here's where Snickers chocolate becomes unique. It's formulated specifically to remain stable at temperatures up to 86 degrees Fahrenheit. Which is why it doesn't melt in your pocket like regular chocolate. This requires adding precise amounts of cocoa butter and soy lecithin, creating a crystalline structure that food scientists call Form 5, the most stable chocolate formation possible. The finished chocolate is then tempered using a process that costs over $50,000 per day in energy alone, but creates that perfect snap you hear when biting into a Snickers bar. The peanut operation at this facility is mind-boggling in scale. Every morning, 18-wheelers arrive carrying 80,000 pounds of raw peanuts. That's enough peanuts to fill an Olympic swimming pool every 3 days. These aren't random peanuts from grocery stores. They're Virginia-type runner peanuts, specifically grown in Georgia's coastal plains, where sandy soil creates the perfect oil-to-protein ratio. Each delivery is tested for 47 different quality markers, including size uniformity, moisture content, and even shell thickness. The roasting process happens in custom-built ovens that stretch longer than a football field. Peanuts travel through these ovens on perforated conveyor belts while precisely controlled hot air circulation ensures even roasting. The process takes 28 minutes at 342 degrees Fahrenheit. Temperatures and timing so specific that they're monitored by computer systems 24/7. What's fascinating is the cooling system. Peanuts exit the ovens at nearly 200 degrees Fahrenheit and must be cooled to exactly 75 degrees Fahrenheit within 4 minutes to prevent oil separation. This rapid cooling uses industrial-grade refrigeration units that consume more power than 500 homes. The final step involves a salting system that applies exactly 2.3% salt by weight, a precision achieved using electrostatic charging that makes salt particles stick to each peanut uniformly. If you think making caramel is simple, prepare to be amazed. Snickers caramel production begins with 10,000-gallon mixing tanks where corn syrup, sugar, butter, and milk are combined in ratios measured to the gram. The cooking process happens under partial vacuum, which lowers the boiling point and prevents the characteristic burning that ruins most homemade caramel. Industrial heating elements bring the mixture to exactly 246 degrees Fahrenheit, while mechanical stirrers maintain constant motion. Stopping for even 30 seconds would create hotspots that could ruin an entire batch worth $100,000. Temperature monitoring happens at 12 different points throughout each cooking vessel, with computer systems making automatic adjustments every 3 seconds. The entire process from raw ingredients to finished caramel takes 2 hours and 15 minutes, with the final 20 minutes being the most critical. Quality control technicians test every batch using both digital instruments and traditional spoon tests that have been used by candy makers for over a century. One failed test means dumping the entire batch and starting over. Creating Snickers nougat requires mastering one of the most temperamental processes in food manufacturing. It begins with dissolving sugar and corn syrup in precisely measured water, creating a syrup that's heated to 250 degrees Fahrenheit under constant agitation. The magic happens when this superheated syrup meets whipped egg whites, but timing is everything. The egg whites must be whipped to exactly 4.2 times their original volume using industrial mixers that consume 75 kilowatts of power. Too little whipping and the nougat is dense, too much and it becomes unstable. Adding the hot syrup requires surgical precision. It's pumped in at a rate of exactly 2.3 gallons per minute, while high-speed mixers prevent the egg whites from cooking into scrambled eggs. The temperature during this process must stay between 165 degrees Fahrenheit and 170 degrees Fahrenheit. Any hotter and the proteins denature, any cooler and the sugars don't properly incorporate. Environmental control is critical. Humidity must be maintained between 35% and 40% because nougat is hygroscopic, meaning it absorbs moisture from the air. During humid summers, the entire nougat production area is pressurized with dehumidified air to maintain consistency. The final nougat contains exactly 12% moisture and has the consistency of thick peanut butter. It's then cooled to 95 degrees Fahrenheit and mixed with ground peanuts before being formed into sheets using rollers that exert 15 tons of pressure per square inch. This is where 4 separate production streams converge in a choreographed dance of mechanical precision. The assembly line operates at exactly 400 bars per minute. Any faster and quality suffers, any slower and costs skyrocket. First, nougat sheets are cut into precise rectangles using ultrasonic blades that vibrate 40,000 times per second. These cuts are so clean they don't compress the nougat or create crumbs that could contaminate other components. Next, the caramel peanut mixture is deposited onto the nougat using computer-controlled dispensers that meter exactly 8.7 grams per bar. The deposition happens at 6 stations simultaneously, with backup systems ready to take over if any dispenser fails. Layer integration happens under hydraulic presses that apply exactly 200 pounds of pressure for 1.5 seconds. This bonds the layers without crushing the peanuts or squeezing out the caramel, a balance so precise it took engineers 3 years to perfect. The layered bars then enter cooling tunnels where temperatures are reduced from 95 degrees Fahrenheit to 65 degrees Fahrenheit over exactly 8 minutes. Cooling too quickly causes layer separation, too slowly allows bacterial growth. Finally, precision guillotines cut the continuous sheet into individual bars. These blades are replaced every 4 hours and must maintain cutting tolerances within 0.5 millimeters to ensure consistent bar weights. The final transformation happens in the enrobing department, where each bar receives its chocolate coating. This isn't simply dipping bars in melted chocolate, it's a precisely controlled process that requires chocolate temperatures within 1 degree of optimal. Bars first pass through a bottom coater, where they travel over a curtain of flowing chocolate that coats the bottom surface. The chocolate flow rate is controlled by high-precision pumps that adjust 50 times per second based on belt speed and ambient temperature. The main enrober creates a continuous waterfall of chocolate that completely encases each bar. The chocolate curtain is exactly 6 inches wide and flows at 1.2 gallons per minute. Any variation creates coating inconsistencies that quality control will reject. Excess chocolate is removed using vibrating wire mesh conveyors that shake each bar exactly 47 times while the chocolate is still fluid. This creates the smooth, even coating while preventing the formation of feet, the chocolate buildup that occurs when coating pools at the bottom of confections. Temperature control is critical throughout this process. The coating area is maintained at exactly 68 degrees Fahrenheit, with humidity below 50% to prevent chocolate bloom. Those white spots that indicate improper crystallization. Each coated bar then receives the signature Snickers ridges, decorative marks created by embossing rollers that also serve as quality indicators. Bars without proper ridges are automatically rejected by vision systems that inspect every bar at 200 frames per second. Packaging happens in clean rooms where air is filtered to pharmaceutical standards. The familiar brown wrapper isn't just decoration. It's a specially formulated barrier film that prevents moisture infiltration and extends shelf life to 12 months. Wrapping machines operate at incredible speeds, sealing 1,200 bars per minute using heat-sealed edges that are tested for strength every 15 minutes. A single weak seal could allow contamination, so backup quality checks happen at multiple points. The wrapped bars are then case-packed using robotic systems that can detect and reject bars with wrapper defects, weight variations, or visual imperfections. These systems process 50,000 bars per hour, with error rates below 0.01%. So there you have it, the incredible precision engineering behind America's favorite candy bar. From temperature control accurate to single degrees to timing measured in seconds, creating a Snickers bar requires coordination between dozens of complex systems operating in perfect harmony. The next time you bite into that familiar combination of chocolate, caramel, peanuts, and nougat, remember, you're experiencing the result of over 90 years of manufacturing innovation, millions of dollars in specialized equipment, and quality standards that rival the aerospace industry. What's your favorite way to eat a Snickers bar? Drop your Snickers ritual in the comments below. Our Process Crate family loves hearing about the unique ways people enjoy their favorite treats. And if this behind-the-scenes look into American candy manufacturing amazed you as much as it did me, make sure to hit that subscribe button and ring the notification bell because we've got incredible factory tours planned that will blow your mind.